Welcome back. This is section 2.2. We will be discussing about test levels. What we mean by test levels is component integration system and acceptance testings. These are different levels of testing. Test levels are characterized by following attributes. For example, the objective of component testing may be very different from integration testing, and objective of integration testing may be very different from system testing, and so is the case with acceptance testing. And the test basis, the basis that we use for designing, developing, and implementing the test cases may be very different for each of these levels. And the test object, that is what we intend to test, right? That is test object, as we saw in the chapter 1. So that may be different. So each level is characterized by these attributes, and then typical defects and failures. The kind of defects and failures that we encounter during component testing will be very different compared to integration testing, and the kind of defects that we encounter during integration testing will be very different compared to system testing, and so on. At each level, each level has a specific objective, a typical test basis, and then a typical test objects, typical defects and failures, and approaches that we employ at each of these levels are very different. Okay. Now, with that understanding, let's look into component testing. Component testing, we also call it as, for example, unit testing or module testing, depending upon how the product is being developed. So the objective of this component testing is to reduce the risk, okay, so that defects do not escape to next levels. Okay, what do we mean by next level? So, for example, a component testing bug which could have been caught in component testing level should not be caught in integration or system testing or acceptance testing. So, this is a general rule. So, what should be caught in a particular level should not be caught in the next level. So that is the idea. And so, for example, objectives could also involve in component testing functional and non-functional behaviors. We want to make sure functional and non-functional behavior of the component are the way we expect them. And also, the objective of component testing is to have a increased confidence in components, and defects are basically captured at component test level itself. And as we said, we don't want the defects to escape to next level. That is the idea. Now let's look at what will be the test basis for component testing. So the component testing is designed on the basis of detailed design. Okay, so by the time we come to component testing, we would have had a detailed design, we would have had a code, and we would have had a component specification. What do we mean by that? What we mean by that is a specification, meaning how the component is supposed to behave, what kind of input it accepts, what kind of output it produces, and things like that. So by the time we are ready with the component testing, we would have had a detailed design, code, and component specifications ready. Now, what are the test objects? What we mean by test objects is what are the things that are getting tested as a part of component testing. As a part of component testing, components or units or modules will be under testing, and then we may be checking code and data structures, we may be checking classes or database modules, right? So these are typically tested in component testing. Now, what are the kind of defects that get caught in component testing? The kind of defects that get caught in component testing are incorrect functionality or incorrect code or logic. Now, what specific approaches do we recommend for component testing. So like for component testing, we may follow test driven development or extreme programming. So in test driven development, we first develop the test cases and then develop the code. So as strange as it may sound, it is basically you come up with the test cases first, and you then code the code in such a way that that particular test cases passes, meaning the intended functionality of the test case for which the test case is written is achieved. Extreme programming is a a relatively newer concept where we do pair programming. So if you are a pilot, you will have a co-pilot, and basically two people or group of people sitting and coding together to ensure the number of bugs are minimal. Okay, now let's look at what is integration testing. In integration testing, we basically concentrate on the interfaces, right? We basically concentrate on the interfaces. So what are the objectives of integration testing? Objectives of integration testing is same, reducing risk and preventing defects escaping to the next level, and we also check whether the functional and non-functional behavior of the interfaces are as intended. Integration testing, interfaces, important, one needs to remember. And then basically what are the bases on which we develop integration testing? Integration test cases we develop on the basis of system design, sequence diagram, interface and communication specifications, use cases and workflows. Okay, so by the time we decide to come up with integration test cases, system design would have been ready, and we will be having sequence diagrams. Sequence diagrams are basically two components interacting with each other on the basis of message flows. So it could be like component one, let's call it as component one, sending certain messages to component two, and component returning back certain message to component one. So basically it could be in the networking software, for particular message there could be ACK or NAC, right? So that is what we are talking about here. And interface and communication specifications. So we here in the specification clearly it would have been told how the interface and communication should happen, and then use cases and workflows. Like what we mean by use cases is in what particular way the particular component is supposed to interact with another component, and how are the workflows organized. Now, what are the test objects? Like what gets tested in integration testing? In integration testing, subsystems, interfaces, APIs and microservices, they get tested in integration testing. So if you have implemented APIs, right? Like for example, APIs are for basically, as the name tells, application program interfaces. It is for two components to interact with each other. So you check those APIs are correct or not, and if at all microservice implementation is employed, we also need to check that. So what kind of bugs we catch in integration testing? If there are any incorrect sequences, okay, interface mismatch, failure in communication, unhandled or incorrectly handled communication. So these things get caught in integration testing. As we were telling, context dependent testing is context dependent, right? So the kind of testing that is done in telecom software will be very different in web compared to that in embedded software, or the way it gets tested in utility software, system software, application software. It is very much domain dependent, but what we discussed some time back, that holds good for integration testing. 2.2.3, that is system testing. Here we test the system as a whole or product end to end. We test product end to end. Now, what are the objectives of system testing? Objectives of system testing is same: reducing risk, preventing defects, going to the next level. What is the next level for system testing? The next level for system testing is acceptance testing. We don't want a system test bug to be caught in acceptance testing. And then, we also check functional and non-functional behavior of the system as a whole. Okay. And system is complete and it works as intended is what we check. And ultimately we ensure the confidence in system as a whole is high. Now again we have to look into three essential things. What are the test bases, test objects, and typical defects and failures in system testing. Now, let's say for system software testing, system and software requirement specifications are the basis. We can also refer at epics and user stories. We can refer at state diagrams and system and user manuals. Now these things we will tell how the system is supposed to behave, right? Basically we will have epics, under epics we will have features, under features we will have user stories. Now these requirements basically tell how the system as a whole is supposed to function, and we use them as a reference for coming up with the test cases. Now what gets tested in application testing, system testing? In system testing, we test applications, hardware, software, operating systems, and system under test. Okay. Now, what kind of bugs we catch? Unexpected or systems functional and non-functional behavior. Now let's say system is supposed to behave in certain way, and if it is behaving in expected way, that is a bug. And end-to-end functional tasks, okay, failures. So if as a system as a whole end to end is not functioning the way it is intended, that is a bug. Those are the bugs that we catch. And we also check whether it is failing to function as described in the system user manuals. So system user manual tells how the system is supposed to behave as a whole, and if there is any deviations, we also check that. And specific approaches and responsibilities, how we approach towards testing is end-to-end behavior of the system as a whole, we check that. Okay. So that is acceptance testing, and now system testing. Now coming to acceptance testing, basically what we mean by acceptance testing is acceptance testing, as we will see, there are multiple ways of acceptance testing: user acceptance testing, operational acceptance testing, contractual and regulatory acceptance testing, and alpha and beta testing. But before that, acceptance testing, as the name itself tells, it is testing which is generally performed by users or operational peoples or contractual and regulatory bodies or end users. Now, what is the objective of acceptance testing? Acceptance testing is, the objective is ensuring confidence in the quality of the system as a whole is high, and it works as expected, and functional and non-functional behavior of the system is as intended. Okay. Now we'll touch upon one by one. What do we mean by user acceptance testing? So user acceptance testing is while we validate the fitness for use by the intended end user. Let's say you are developing a particular software with particular user in mind. The software is supposed to behave is supposed to behave as intended for that end user's purpose. Okay. And operational testing, operational acceptance testing is done by operational teams. Like basically, there they check whether backup and restore is happening properly or not. Install uninstalls are happening properly or not. Upgrade and disaster recovery is happening properly or not. Okay, data loading and migration, whether it's happening properly or not. Okay, so those things are tested in acceptance testing. Now next thing is contractual and regulatory acceptance testing. Here, if you have developed a custom made software for for a particular contract, then you need to make sure the custom made software is functions as intended by the contract. Okay. Now, the next thing is alpha and beta testing. These come under acceptance testing again. If you have developed uh, commercially available off the shelf software, alpha testing generally happens at the developing organization site, and then beta is done by uh, potential end customers or existing end customers. Okay. Now let me talk about a practical example where all these things were employed. This was in one of the projects that I had worked in, my first company. Basically, let's say if there is a Unix process which is supposed to accept a command and it is supposed to generate a byte stream, right? Now, you will supply various combinations of inputs and you will check whether the particular intended byte stream is getting constructed or not by component. Okay, so and then you come up with stubs and skeletons to make sure the intended byte stream is getting generated. Now this intended byte stream is for the consumption of another Unix process, right? So now in the integration testing, you will put two components together, two Unix processes together, and make sure when the command is issued in one Unix process, intended byte stream are getting generated and getting sent to another process, and another process is interpreting it as correctly. Now what do we mean by system testing? You will have multiple processes on operating system, and then you check all of them together, and then acceptance testing is basically whoever is supposed to use this system in the end, you give the system to them and get it checked. So that is beta testing, what I was talking about. So you do all these things to ensure the testing is done in entirety. Thank you. Let's meet in 2.3.